This is TWiT.
Tech Break is brought to you by ACI Learning. Save time and money while implementing the exact training your company needs, be it private training for one department or an enterprise-wide solution. ACI Learning helps you create the perfect training solution for your business. Visit acilearning.com and learn how ACI can power up your IT team. One of the things you do in this, which is great, is you actually let Nathan Joyce tell the larger story.
The master plan.
The master plan of our future.
Yeah.
And I thought that was really interesting because it sounds to me, that one is I almost hear Daniel Suarez saying, folks, this is what we need to do.
Yeah, I definitely believe that. And it is also, all I would say is that there is an element of risk here that is quite large, that people will be going into danger and that we have to recalibrate what we perceive as risk when it comes to space. And I say that because of the risk of doing nothing, I think is greater, or moving too slowly, for all the reasons that I mentioned just recently. You know, we have billions and billions of people who require for their futures. I mean, there's 3 billion people some odd who are living at bare subsistence level, and they want to improve their condition for themselves and their children. And if everyone on Earth starts living at a first world level, we are really going to poison the Earth. But it's also unfair that only some people. So the idea of availing ourselves of new energy and resources in space, bringing that to bear to Earth through, you pointed at one of the solar power satellites, sending microwave energy, clean microwave energy down to Earth. Now people see that and they immediately see a death ray. And I would point out that we're talking 100 watts per square meter, maybe 200. What you could stand in that beam.
It's using microwave.
It's using microwaves. And this, again, is a technology that has been around, was conceived of way back in the 70s. We use this technology for cellular communications, and, you know, birds fly through the beam all the time.
Right.
I understand why people are concerned and they see those big solar power satellites and they think it's a death ray. But to that, I would say, everything is visible in space. And if you put this large 4 or 5 kilometer wide solar power satellite in space, everybody's going to see it. And if you start to change it and turn it into a weapon, it's going to be very apparent. And people will have lots to say about it. And it is also uniquely vulnerable.
So this solves a big problem, which is energy.
Energy, clean energy that does not further heat up the Earth. Because again, you're intercepting solar power that really is heading towards the Earth anyway.
Just focusing it.
You're focusing it at a certain frequency and sending it down to a receiver called a rectenna, which can absorb it. Now, this is where I think a lot of people say, yeah, but the converting that energy into a microwaves up in space and then sending it down, then reconverting it back into the grid, by the time you're done, it's 9% efficient. But
what?
Yeah, well, that's one thing, especially if there's chaos on the planet, right? If, let's say, there's a mass migration or wildfires or economic collapse, this is in space, so it will be invulnerable to that. But the other good thing is you're sending that clean energy wherever it's needed. And
you can move these rectennas easily.
You don't even necessarily have to move them.
Yeah.
Anywhere in the hemisphere beneath it, let's say in geosynchronous orbit, you can beam that energy. You can adjust
you can aim the satellite.
You can adjust it without any moving parts. You can direct it to various, or you can bifurcate it. You can split it and send it to different cities. And the rectennas are very cheap to build. And like I said, you could even stand in the beam and you will not get fried. And one more little thing is that you could actually grow crops underneath it. You could put this above pasture land.
Most of the sun gets through.
Most of the sun gets through. So.
What a cool technology. We've heard, as you said, we've heard about this since the 70s.
And there are tests coming up, by the way. They are doing a test soon.
A lot of the cost of doing this is getting it out of the gravity well of the Earth.
Correct. And
so now you see why it's important that we have this material in space that you could then construct these.
That's right. That one right there is about 7,400 tons. That was John Menken's design. That's an SPS Alpha, I think, 2. I think it's his second design. But again, it's very modular, can be made with robotics. So they could mass produce them as long as they have the mass in deep space. You put those into geosynchronous orbit. We could put thousands of them in geosynchronous orbit and beam terawatts of energy back to Earth. And that could help us remove CO2, because that's the big question. We see this with Climeworks and companies like that, pulling CO2 out of the air. Where are you going to get sufficient clean energy to do that. And
So it's-
geothermal is thought of sometimes.
You don't do this kind of as Starlink is being done, where you're launching these from the Earth and putting them up in orbit. Ideally, you would start with harvesting materials in space, either on an asteroid or
At
on
this
the moon.
scale, you kind of have to. Because again, 7,400 tons, that gives you about 2 gigawatts that you can beam back.
Right.
And if you want hundreds and hundreds of these, that we're talking hundreds of thousands and millions of tons, you're going to want to do in situ resource utilization, either from a near-Earth asteroid or from the surface of the moon. And that's where a mass driver comes in.
It's a really exciting future that you're envisioning. I just hope you're right, because if we don't do this, it's going to be difficult. I mean,
But notice the feeling you have, right? It is a hopeful thing, and it's also not BS. It isn't, in the sense that
it exists.
And Gerard K. O'Neill wrote about this in The High Frontier. Peter Glaser, these were scientists who, and NASA has checked out the economics of it. It's just a matter of getting the working mass, which is why that's called critical mass, because it is critical. It's also a critical mass of opinion to support this here on Earth.
Right. Political will to do it.
Yes.
Yeah. And do it soon before it's too late, really. I mean, we don't have a lot of time.
We don't.
It's not the launch windows the problem. It's getting the political will to do this.
Exactly. Yeah, we have about 10 years to get started. And the good thing about it, though, is I think it would bring us together around the world. There's a tremendous opportunity for economic growth as well.